How does E. coli cause leafy greens outbreaks? Following last week's story about the cost of an outbreak caused by Shiga-toxin-producing E. coli, and I'm going to call that STEC, the one that caused the outbreak was serotype 0157H7. Anyway, following the last week's story about the STEC outbreak in leafy greens, it's time to talk about root causes. And just as a reminder about that story, hundreds of millions of dollars of losses were incurred by industry and consumers, all from contamination at just one farm. 2 outbreaks. There were 2 unrelated E. coli outbreaks from romaine lettuce in the USA in 2018, with a total of 5 deaths. In addition, 29 people suffered serious kidney failure from haemolytic uremic syndrome. 121 people were hospitalised, and there were 272 officially reported cases in total. The smaller outbreak in terms of numbers of illnesses was the one that was analysed by the economists and reported in last week's story. Which foods made people sick? The first step in an investigation outbreak usually involves interviewing the victims about what they've eaten. It takes up to 8 days to become ill with Shiga-toxin-producing E. coli. In these outbreaks, victim food recall information pointed to romaine lettuce as the outbreak source. The lettuce was traced back to certain growing regions, but it was not possible to trace back to individual farms. In the growing regions, authorities then began taking samples of water, soil, and manure looking for bacteria with an exact genetic match to the bacteria isolated from the outbreak patients. In the first outbreak, the outbreak strain of STEC was found in the water of an irrigation canal in the Yuma growing region, that's in Arizona. The US FDA concluded that the food responsible for the outbreak was romaine lettuce from the Yuma region. In the second outbreak, the outbreak strain was found in sediment in an agricultural water reservoir on a farm in Santa Barbara County in California. The FDA concluded that the source of the second outbreak was romaine lettuce from that farm. The 2 outbreak strains from 2018 were not related. That is, the genetic patterns of the bacteria were not very similar. However, the strain from the second outbreak was closely related to one that caused an outbreak the previous year. Fresh leafy greens such as romaine and spinach are a common source of E. coli food poisoning. Romaine has been implicated in more STEC outbreaks than other types of lettuces and leafy greens. There are a number of reasons for this. Romaine lettuce is grown outdoors in the USA, and its leaves are close to the ground, which increases the chance that the edible parts of the plant will be exposed to bacteria in soil and water. The lettuces require a lot of irrigation water when growing. They're popular foods, which increases the likelihood of them causing an outbreak, and they're usually eaten raw. Compared to other lettuces, romaine is open at the top, whereas iceberg lettuce, for example, has outer leaves that are closed and divert water away from the centre, so irrigation water or soil might come into contact with more romaine leaves per plant compared to iceberg. The lettuce that caused both outbreaks came from farms where there was pathogenic E. coli in water canals or water reservoirs. The presence of the bacteria allowed authorities to conclude that those regions or farms were the sources of the outbreaks. Good to know! Shiga-toxin-producing E. coli is quite rare compared to generic E. coli, which is not always pathogenic. Microbiological surveys of hundreds and even thousands of leafy green samples frequently detect no instances of E. coli 0157, including surveys of samples that were grown using manure fertilisers. How does bacteria like E. coli get into or onto lettuce and stay there through washing, packing, and other processes? It's thought lettuces become contaminated from exposure to water or soil that contains STEC from animal sources near lettuce-growing farms. The contamination can be caused by cattle, wild pigs, dairy farms, or concentrated animal feeding operations, such as cattle feedlots. One study noted that water near cattle was more likely to have STEC than other water. You can also find STEC in cattle feces. So it does seem that lettuce grown near sources of contamination is more likely to contain STEC. However, we don't really know for sure how E. coli gets into or onto lettuce. There's evidence that it can be taken into the inside of leaves rather than always being on the outside of leaves when plants are exposed to contaminated water or soil. STEC can be recovered from leaves for many days or weeks after being sprayed onto leaves. Dust that carries the bacteria may also be responsible for some leaf contamination. Once on or in leaves, it persists and can be detected for 45 days, or in one study, even up to 177 days. Research conducted in 2020 showed that the surfaces of spinach leaves have features that help E. coli to adhere to leaf surfaces, with the density of veins on the spinach leaves being an important factor in adhesion. Once attached, E. coli was not easily washed off leaf surfaces, even when the wash water contained detergent and chlorine. How to prevent outbreaks like this? After the 2018 outbreaks, a number of recommendations were put forward by experts and government agencies. The USA has already passed a law called the Final Rule for Produce Safety, but it has not yet been fully enforced. An important part of the produce safety rule is frequent testing of agricultural water to make sure it's free of pathogens. The two largest growing areas for leafy greens in the USA, California and Arizona, have made their own recommendations for growers, which include having larger buffer zones between concentrated animal operations and leafy growing fields, and categorizing sources of water, testing water, and even treating water to remove pathogens if they are found.